Continuing on with trig functions, this video will be about different trigonometric identities. So these identities are equations that hold true for all cases. So we're going to start off with the Pythagorean identity. So here we have sine squared of theta plus cosine squared theta is equal to 1. Next, we have the addition and subtraction formulas. So here, if we have two angles, alpha and beta, if we were to add or subtract the two different angles, we'd be able to find the equivalents through these formulas here. We also have the double angle formulas, where for any angle theta, we can reduce an angle of 2 theta into terms of just theta. Conversely, we also have the half angle formulas, where for any angle theta, we can double it here. Okay. So let's go ahead and now try using some of these trig identities. So feel free to pause this video and write these down, so then you're able to have these easy to access. So firstly, proof over here. Prove that cotangent theta plus tangent theta times by cosine theta is equal to 1 over sine theta. Okay. So firstly, we can recall that tangent is just sine theta over cosine theta, and so cotangent will be the reverse. So let's first get rid of cotangent and tangent and just write this in terms of sine and cosine. So firstly, cotangent is just cosine theta over sine theta. Tangent is just sine theta over cosine theta. And I'm gonna just times that by cosine theta. So let's continue working on the left-hand side first. So let's go ahead and expand out of these brackets. So the first term will become cosine squared theta over sine theta. And then the second term will simply just become sine theta after expansion. So let's go ahead and put them all in one fraction. And to do that, I'm going to go ahead and make sine theta as the denominator. And in doing so, I would then get this equation over here. And from the Pythagorean identity, we see that cosine squared theta plus sine squared theta is just 1. And so we get 1 over sine theta, which is exactly what we needed. So we have proved this equation. Okay, let's go ahead, let's try another proof over here. Cotangent theta plus cotangent 2 theta is equal to 1 over sine 2 theta. So again, I'm going to focus on the left-hand side and see if I can try and reach the right-hand side. So for cotangent, I know that's equal to cosine theta over sine theta. And then I can go ahead again. Here it's 2 theta, so it'll be cosine 2 theta over sine 2 theta. Okay. Now, let's go ahead and try and find all these values in terms of the same theta, because having 2 theta and a single theta here is preventing us from combining things. So I'm going to leave the first term as is. And for the second term, I'm going to use the double angle formulas to reduce our theta, the 2 theta to just theta. So cosine 2 theta, according to my formula, is just 2 cosine squared theta minus 1. And sine 2 theta is 2 sine theta cosine theta. Okay, so then now let's go ahead, find the common denominator, which in this case would just be 2 sine theta cosine theta. And then so to the first term, to make it like this, what I would be doing is timesing it by 2 cosine theta, which means it will become 2 cosine squared theta. And then I have my second term over here, doesn't need to change yet, so minus cosine theta squared theta minus 1. Which, after we simplify these terms, those 2 cosine squared thetas will eliminate each other. So then I would just get 1 over 2 sine theta cosine theta, which, according to my formula, we know is just sine 2 theta. And again, I have now proven that the left-hand side is equal to this right-hand side. And so that is some exploration with trig identities.